is called Formulas 3 session, and it's going to be on molecular compounds. To give a quick review, in the first couple of tapes, we talked about ionic compounds. And let's just quickly go over ionic. This is where you have metal ions, called cations, combining with nonmetal. Now, groups 1, 2, 3 are metal. In fact, group 3 is called a metalloid, and the rest of these are nonmetals. And they go down, the nonmetals go down in a step-like fashion, you'll see. So you have more metals than nonmetals. So these compounds have high melting points. They're solids. In groups 1, 2, and 3, they're usually always white. They're crystalline. And in general, they're soluble in water. The best thing I say about them is they're predictable. Now, what does that mean? If you take something like lithium, it has one valence electron. If it loses that electron, here it is. We'll do a little, looks like a football play here. Lithium loses the electron, and we're going to put oxygen over here with its 6 electrons. So lithium could lose 1 electron to this oxygen, and another lithium could lose an electron. And the reason these two will each lose 1, because oxygen gets an octet, has 8 electrons, and lithium, by losing its electron, goes back to a noble gas configuration of helium, or shape. So you get a compound, Li1 plus, oxygen 2 minus LiO2. But when you get over here with the nonmetals, you have a real problem. Nitrogen and oxygen combine in about 9 different ways, but none of them involve gaining or losing electrons. They're involved with sharing electrons, and they are not predictable. So molecular compounds, we'll tell you right off, are not predictable, and there are many more molecular compounds than ionic. There are hundreds of thousands of molecular compounds. The reason we'll discuss in later tapes, one of the reasons is because of the element carbon. It produces so many thousands, hundreds of thousands of compounds. So let's look at nitrogen and oxygen. Nitrogen and oxygen combine as 1 atom of each. They're gases normally. They're extremely low melting points, way below 0 Celsius. So they're a gas at room temperature. And they are absolutely non-predictable. Because there's no charges here. So you can have NO, NO2, N2O, N2O4. Those are the ones that I'm most familiar with. There are about 9 different ones of these nitrogen oxide. NO2 is very interesting. It's used with dentists. NO2 is a very nasty pollutant, as is NO. How do we name these things if you don't have the metal and the ending IDE with an ion? Well, we use, the first way we can say it, naming, we use prefixes for the number of atoms in the molecule. And notice I said molecule, these are single units, whereas Li2O is a crystal, and there are millions and millions of these in a crystal. These are single units, 3 little atoms, NO2 combined. 6 little atoms, N2O4 combined. To name them, we use prefixes. Mono, di, tri, tetra, penta. 1, 2, 3, 4, 5. And then hexa, hepta, octa, nona, and deca. So here's how we name them. First rule, we look at the first one, NO. This is called nitrogen monoxide, 1 atom. Now, why is it called nitrogen monoxide? There is a rule. And we'll just number these out here, go across the rule. The rule is here, if it starts with a single atom, you don't use mono. No mono. No mono. So, for instance, the familiar compound CO in CO2. This is not called carbon monoxide. This is called carbon monoxide. So for a single atom, initially, we'll say the initial single atom. We don't use it. Okay. Another thing to keep in mind as you name these, there are some common names. And we'll just list these out. For instance, a common name could be NH3. This would normally be called nitrogen trihydride, but this common name is ammonia. Here's one you're familiar with. This should be dihydrogen monoxide. What do we call it? Water. This is a very common compound. Carbon tetrahydride, no, it's called methane. So there are a number of common names. And there's a fourth minor rule, that is, if you have a prefix like penta, P-E-N-T-A, and it follows by a name with a vowel in it, like diphosphorus, we'll list this down here, P2O5, diphosphorus pentoxide, P-E-N-T. You don't say penta. Okay, so because the oxide is a vowel. If it is phosphorus PCl5, it'll be phosphorus pentachloride, because chloride is a constant. The consonant you follow through with the A's. Simple rule. Now, these compounds range from a couple atoms together as simple as oxygen diatomic or nitrogen diatomic, and they can literally go into the tens of thousands of atoms in biochemical and organic chemicals that you could learn in upper classes, graduate classes, normally. Okay, so let's see what we did. What we did is we said all these are single units. Dinitrogen monoxide, for instance, is a single unit. Incidentally, dinitrogen monoxide is laughing gas. It used to be used as an anesthetic, and it was actually used by British upper class in on the 1780-90 range as party gas, recreational gas. Well, we're going to stop right there on this unit.